Hello, my dear friends. Welcome to science class. I am Soham Jagad. We are in chapter number 1, and in previous lecture we have seen that what is matter, definition of matter, nature of matter, and properties of matter. In last lecture we have seen different states of matter. In different state of matter, first of all we have seen solid state. We have example of solid like chalk, chair, table, etc. are example of solid state or solid objects. We have seen some properties of solid with various activities. In that we have seen that all this solid have definite shape. They cannot flow. It has fixed volume and they change their shape or break when force is applied over some limit. After that, we have seen liquid state. In the liquid state, we have example like water, cooking oil, milk, juice, cold drink, etc. In that, we have seen that liquid have fixed volume but not definite shape. It can acquire shape of whatever the container have shape. So liquid has fixed volume but not definite shape. After that, we have seen that particles of liquid moves faster compared to particles of solid. Particles of solid are rigidly tight and force of attraction between two particles is comparatively more in solid, whereas in liquid we have comparatively lower, less force of attraction compared to solid. After that, we have seen one concept of diffusion, that one state of matter is dissolved into other state of matter. In that we have seen that gases like oxygen, carbon dioxide dissolved into water. So that is the dissolving of gases into liquid. In that we have seen one reason how aquatic animal and plants get required gases underwater. In that we have seen that the aquatic animal can breathe underwater due to presence of dissolved oxygen in it. Thus, we may conclude that solid, liquid and gases can be diffused into liquids. We have seen examples of diffusions of solid, liquid and gases into liquid. Rate of diffusion of liquid is higher than the solid. That is clear because the particle of liquid are has more kinetic energy compared to solid. so they get more dissolved. This is due to the fact that liquid particles move freely and have greater space between each. As we discussed, compared to solid, liquid particles have more movement. More movement means more kinetic energy, and due to this more kinetic energy and more space, they can dissolve more. Now we have our third state of matter, that is gaseous state. As the name suggested, gaseous state, which means here we are talking about gaseous form. Have you ever observed a balloon seller filling a large number of balloons from single cylinder of gas? Yes, we have observed balloon seller. He has one cylindrical type of vessel which is filled with few chemicals, and due to that chemicals it releases gas, and he fills large number of balloons from that single cylinder of gas. Inquire from him how many balloon is able to fill from one cylinder. Ask him which gas does he have in the cylinder. So we know that we can fill many balloons from that single cylinder. Now we have one activity, activity number 1.11, to understand difference between properties of solid, liquid and gases. Take 100 ml syringes and close their nozzle by rubber cork. Here in the figure we can see that this is the syringe, and we close this mouth of syringe with rubber cork. So whatever the material we filled in the syringe cannot come out. So we have three syringes. We block the nozzle or say mouth of syringe with rubber cork. Remove the piston from all syringe. This is the structure called piston. Here we can see, here in syringe, this is piston on which we compress. Leaving one syringe untouched, fill water in the second and piece of chalk in third. We have to take three syringes. In one we have to fill nothing. In second we have to fill water, and in third syringe we have to put pieces of chalk. Insert the piston back into the syringes, and now we have to fix piston into syringe. You may apply some Vaseline on piston before inserting them into syringe for their smooth movement. We know that if we lubricate the surface of pistons, we can have smooth movements. You may heard that we change engine oil or gearbox oil. So what is the use of these oils? This oil called as lubricants, and this lubricants helps smooth movement and heat transfer in particular object or machine. So here also we can apply Vaseline on the piston for its smooth movement. Now try to compress the content by pushing the piston in each syringe. Now what we have to do? We have to compress it. We have to compress this piston. Apply force on this piston and try to compress it. What do you what do you observe? In which case was the piston easily pushed in? By the experiment, we can see that we can push air, that is our first syringe in which we filled nothing. We filled nothing, which means that it has only air in it. So the air is in gaseous form and we can compress it easily. So we can say that the air, which means the gas, can compress easily. Whereas we have other two syringes. One syringe was filled with water and another syringe was filled with chalk particles. But we cannot compress both of these syringes. So we can say that solid and liquid are not easy to compress, or we can say they are incompressible. They have minute compression between particles, but we can neglect it. So we can say that solid and liquid are incompressible. What do you infer from this observation? As we discussed, we have observed that gases are highly compressible as compared to solid and liquids. Gases are highly compressible compared to solid and liquid. The liquefied petroleum gas, we have to remember this name. We heard about LPG, and the full form of this LPG is liquefied petroleum gas. So this LPG cylinder that we have in our home for cooking, we get it our home for cooking, or oxygen supplied to hospital in the cylinder is compressed gas. As we stored these gases, we compress it in a large amount and then we filled in cylinder. Compressed natural gas, we also heard that we have CNG kit in our car. We have LPG kit in our car. Here on highway we have CNG filling fuel station. So what is that CNG? CNG is compressed natural gas. We have to remember this full form of CNG and LPG. CNG is compressed natural gas and LPG is liquefied petroleum gas. Why LPG is called liquefied petroleum gas? Because when we compress it, it transfer into liquid state. So we called it liquefied petroleum gas. And compressed natural gas, it has some substance we called as natural gas. It has some basic substance or gases in it. So it is called compressed natural gas. is used as fuel these days in vehicle. We use this gas CNG in our automobile. Due to its high compressibility, large volumes of gas can be compressed. So we can fill large amount of gases in small cylinder, and due to this its transportation will be easy. So we have two gases, LPG called liquefied petroleum gas and CNG called compressed natural gas. We came to know of what is being cooked in our kitchen without even entering there by smell that reaches our nostrils. As we enter in our home, we can say that what is what is cooking in our kitchen because we have smell of that food in our nostril. How does this smell reaches us? How does this smell reaches us? The particles of aroma of food mix with the particles of air. Particles of aroma of food mixes with particles of air, and this particles of air has its kinetic moment, kinetic energy, so it transfer from one place to another place, so it reaches our nostril. The particles of aroma of food mix with the particles of air spread from kitchen reaches us and even farther away. It travel more distance due to more kinetic energy. The smell of hot cooked food reaches us in seconds. Compare this with the rate of diffusion of solid and liquid. Rate of diffusion of solid and liquid is comparatively lower, while rate of diffusion of gases is comparatively higher. Due to high speed of particle and large space between them, gases show the property of diffusing very fast into another gases. We have one statement. Gases shows the property of diffusing very fast into another gas, which means one gas can mix with other gas very easily and fastly compared to liquid and solid. And we can ask for a reason behind this. So here we have a reason. Due to high speed of particles and large space between them. Due to high speed of particles and large space between them, gases show the property of diffusion very fast into other gases. So here we can say that diffusion of gases is comparatively higher. In the gaseous state, the particles move about randomly at high speed. In gaseous state, movement of particle is very high and it has random arrangement and random movement. Due to this random movement, the particles hit each other and also the wall of container. Due to this movement of particle, it hits each other and also walls of container. Here we have figure of solid liquid and gases. Here we can see the structure of solid is tightly packed. Here we can see the molecules. Here the black dots represents the molecules of any matter. Here we have solid. We can see that the particles of solid are very near to each other and closely packed in comparison with liquid. Here in liquid, we can see that there is a less particles or less molecules in same space. You can observe here the particles of solid are more and here the particles of liquid are less. Due to loosely packed structure and more space between them, it has higher kinetic energy compared to solid. Liquid has higher kinetic energy compared to solid, which means that the molecules travel from one place to another place. Particles can travel easily compared to solid. Now in case of gas, you can see that very few particles of matter can be seen in the same amount of place. So they are very loosely packed. Attraction between these particles are very less. Here in liquid, we have comparatively higher attraction compared to gases, and in solid we have highest attraction between particles of matter compared to both liquid and gases. So here we have figure ABC. Show the modified schematic picture of three states of matter. The motion of particle can be seen and compare the three states of matter. We have highest motion in gases, comparatively less motion in liquid, and we have least motion in solid compared to liquid and gases. Due to this random movement, the particle hit each other and also wall of container. So we can see here liquid gases exert pressure on wall of container, and here we have the reason why they exert force on walls of container, because the pressure exerted by gas is because of this force exerted by gas particles per unit area on the wall of container. Here we can see the movement of particles of gases. Due to this movement, it can hit to the wall of container. So here we have force, and now we know that force per unit area, that is pressure. Thrust per unit area, that is pressure. Now we have topic, can we matter can change can we mat can matter change its state? Before going to change in state, we have to see comparison between these three states. Here we have one table that shows us comparison between solid, liquid and gases. Why this comparison is essential. We have seen in depth solid, liquid, and gases, but we can easily remember it by placing in tabular form, and we can easily remember it by comparing with each other. So here we have difference, or we can say comparison of solid, liquid, and gases. First point in solid, solids are rigid in comparison to liquids and gases. As we seen that solids are rigid, the liquid is not so rigid. Liquid is comparatively less rigid, and gases are also not rigid. Gases are not rigid. Solid, we have second point. They have a definite shape and volume. As we seen here, if we have any solid object, it has definite shape. In previous lecture, we have seen one activity that involves tracing of border of solid object. From that, we can see that liquid, solid have definite shape and volume, while liquid have not definite shape but it has definite volume. Second point, important point in liquid, they have definite volume but no definite shape. Why not definite shape? Because as we transfer liquid from one container to another container, it acquires the shape of that particular container. And why it has definite volume? Because in activity we have seen that if we take 50 ml of liquid, it remains 50 ml in every container. So it has fixed volume and fixed shape, or not fixed shape in liquid. Gases. Gases have no fixed shape and no fixed volume. Gases can acquire the volume of any kind. Let's say we take one example. Let's say we have one gas. Suppose we have helium with us. Now we have helium in container, let's say size of 1 feet cube. We have volume of that container is 1 foot cube. Now in one room we open this box or say container. What will happen? The gas will release. What do you think now the volume of helium gas which we have initially in that container, 1 foot cube container? Now the volume of helium gas is volume of that room if it is closed. So we can say that gases have neither definite shape nor definite volume. Solid particles have least kinetic energy, while liquid molecules have intermediate kinetic energy, which means it has higher kinetic energy compared to solid and lower kinetic energy compared to gases. that is we called as intermediate kinetic energy. Now we have gas. Gas possess very high kinetic energy. Gases possess very high kinetic energy. We have third point, fourth point in solid, can't compress appreciably, which means we can compress solid by least amount. Liquids here written that can be easily compressed, but liquid can also not compressed easily. Liquid can also not compressed easily. Gases can compressed easily to some extent. Gases can compressed easily. So here the point is on compressibility. Their molecules are held rigidly by strong nuclear forces, which means it has strong bond between two particles of matter. In liquid, this bond is at intermediate level, which means lower than solid but higher than gases. But in gas, this attraction force is least, lowest in gases.